All right, guys, so before we get started, we're going to look at 751, problem number 19. 7.51, problem number 19. Restrictions. There's only a variable in one of the denominators and it's by itself, so x cannot be 0. Now, the first thing we want to do in solving is multiply everything by an expression to get the denominators to simplify. For the first one, all right, guys, let's focus in. We're going to multiply by 2 to get that first denominator to cancel. But it didn't cancel all of them. We also have x. Now, the x over x will cancel in the middle, leaving us with 3 times x plus 1 times 2. And our 2 times 2x is 4x. Bless you. Bless you. Questions on what we've done? We good with this here? Now, since we don't have x squared, x to a power other than 1, we just need to get x by itself. So we would subtract 3x from both sides. 3x and 3x would cancel. 4 minus 3x is x. Equals 2. That's it. And if we wanted to check it 3/2 plus 1/2 and see if it does equal 2, well, it would be that calculator is not opened up yet. 3/2 plus 1/2 is indeed 2. So that is the correct answer. As if x is 0, let's back all the way up to the start before I cross anything out. So if we said x was 0, and I plugged it in here, we'd have 3/2 plus 1 over 0 is equal to 2. So this 1 over 0 here doesn't work. Does that make sense? So we remove any value that would make a denominator be 0. That would cause one of the bottoms of the fractions to be 0, cause that division of 0. And we take them out at the beginning. Because if, for some reason, we solved this out and got x equals 0, we can immediately throw it out. Because it's not going to work. It's going to cause that division of 0. Does that make sense? Because if we look at this next one here, well, we need to because we have 2 spots where we could have restrictions. X plus 3 and x minus 3. Because if either one of these, x plus 3 or x minus 3, became 0, we would have a division of 0, and it wouldn't work. Those points, the values of x that would make x plus 3 or x minus 3 be 0, have to be removed. So for x plus 3, we'd subtract 3 from both sides, telling us that if x is equal to -3, we have a division of 0, so it doesn't work. X minus 3, we would add 3, telling us that if x is equal to +3, we'd have a division of 0. It doesn't work. We don't have a value there. Now, we do need to make sure to factor our last denominator, the x squared minus 9. Luckily, it does factor nicely. 2 x plus 3 and x minus 3, because it's the difference of perfect squares. And one of the other nice things is it doesn't add an extra factor that we have to find a restriction for, because x plus 3 and x minus 3 were already listed, so all of our restrictions are there. They're listed. We have them. Questions on this here? We good with this here so far? Okay. Now at this point here to solve, we're going to multiply by the least common denominator, a scalar, to reduce every fraction, to get rid of them. So that's one thing we multiply by. X plus 3 and x minus 3. And if you're not sure you have them correctly or know which ones to pick, or if you need more than one, do it one at a time. Because with the first one, we have 1x minus 3, and it's going to cross out 1x minus 3 on top. That one's completely gone. The middle one, we have an x minus 3, 1x minus 3, 1x plus 3, 1x plus 3. And then the last one, we have a single x plus 3, simplifies out with one of our x plus 3's. And for this one here, we didn't need x plus 3 or x minus 3 more than once, because in each of the denominators, it only shows up once in each case. We don't have an x minus 3 times x minus 3. Questions on this here? Now, when we look at what's left, so 6 is being multiplied by x plus 3 is equal to our middle term. We had 8x squared, but everything we multiplied by it simplified with the bottom of the fraction, so it is just 8x squared minus 4x times x minus 3. So really the big step in solving these rational equations is just knowing what to multiply the whole thing by, because once we do that, now we simplify from here. So for the left-hand side, we're going to distribute the 6. 6 times x is 6x. And 6 times 3 is our positive 18. Equals 8x squared. Here, we're going to distribute the negative 4x. Negative 4x times x is negative 4x squared. Negative 4x times negative 3 is plus 12x. At this point, we'll combine like terms. Because our 8x squared minus 4x squared is 4x squared plus 12x. Now either direction we move this one, it's going to be two moves. I'm either moving two things from the left to the right or two things from the right to the left. Personally, I try to keep the variable with the biggest exponent positive. If it's equal in the amount of moves, if it's less to move the term with the biggest exponent, I'll move it and then adjust the sign later. So here, well, it doesn't matter what we move first. We could subtract the 18 from both sides first. And have 6x is equal to 4x squared plus 12x minus 18. Then we can subtract the 6x. Minus that 0 is equal to 4x squared plus 6x minus 18. Questions on this here? Now we could start with not factoring, but graphing it. But there's a good chance we're going to get rational, fractional answers. Part of the reason I know that is the number in front of x squared is 4. If we have a number in front of x squared, the likelihood that there's going to be a fractional answer, 1 if not 2, is very high. But just to make sure, is there a greatest common factor between these three? 2. And we can reduce that out. Take that factor of 2 out. Minus 0 is equal to 2x squared plus 3x minus 9. Well, we still have a value in front of x squared, yes? So most likely, and it is the case, one of them will be fractional, one of them will not. So we're going to get one non-fractional answer, one fractional. So We could graph it. It would give us one of them, but we'd have to factor it anyways. Flies. Now, looking at this here, since our third term's negative, our signs are positive, negative, opposite. Factors of 2x squared, 2x and x. I'm guessing we'll just put the 2 in the first spot. Factors of 9, 1 and 9 or 3 and 3. Which one do we want to try first? 3 and 3. I have a feeling that we're going to have to make a change to this setup because 2x times negative 3 is negative 6x. 3 times x is plus 3x. So we need to switch the signs. Luckily, the only one that we really have to change is the addition sign, because changing a minus to a plus is just adding one line. Because that would give us 6x minus 3x, giving us positive 3x. Questions on this here? Zero product property. Anytime we have two things multiply together to equal 0, means one of them must be 0. Now for our 2x minus 3, we'd add 3 to both sides, telling us 2x is equal to 3. Divide both sides by 2, telling us x is 3/2, 3/2. The other one, we would subtract 3, telling us x is equal to negative 3. Exactly. Negative 3 came up as one of our restrictions, and since it also came up as a solution, that one doesn't work. And that's one of the nice things with the restrictions, listing them first, because as this one did here, negative 3 came up as a restriction, yes? When we check our answers, it's just looking back. Is one of these values a restriction? If it is, we remove it. The other one works. We don't have to individually plug them back in to make sure they work. The restrictions tells us outright. This one's not going to work. Don't even have to check it. This one doesn't work. Questions on this here? Well, I will tell you this here. The numerators, when we solve these rational equations, it does not matter if they are factorable. I'm going to change it here for a second, then I'm going to erase it. Like if the middle term had been x squared minus 1, that is factorable, yes? Leave it alone. Because again, when we solve after we multiply through, well, we're going to have to multiply, yes? That x squared minus 1 is going to have something multiplied by it to get the fractions to reduce, yes? So if I rewrote it as x plus 1 and x minus 1, we'd have to completely undo that. We'd have to multiply that back out, plus whatever we're multiplying the whole thing by. So whenever we're solving these rational equations, and this is specifically with solving, because the only one multiplication and our division, factor everything to begin with. Addition, subtraction, factor those denominators. Here, we're looking at factoring the denominators because the numerators, we're going to have to combine like terms. We're going to have to multiply by something. So factoring it just gives us more work. We have 3 denominators, yes? One of them doesn't factor. X plus 3, that is as simplified as it gets. There's no greatest common factor, and the biggest exponent's 1. Now the other two, x squared minus 9 is a little bit nicer than the other, yes? And that'd be x minus 3 times x plus 3. It's a difference of perfect squares. And the last one, I know this partially because I've done this problem a few times for several years, but also it's just going to work out nicely. It is indeed, because here signs are the same, minus and minus, x squared is x and x, and we're going to have 3 and 3. That's why I'm saying it works out nicely, because we're not getting additional factors from it. Restrictions. X cannot be plus or minus 3. I kind of just jumped to that mainly because I think we can see that in B. We did that not a few minutes ago. We did that on the last one too. Because at this point, we're setting the denominators equal to 0 and seeing what value of x will make them be 0. Questions on any of this here? What do we need to multiply everything by? X minus 3, x plus 3, x minus 3, x plus 3. Okay. Watch this here for a second. Don't write anything. I'll tell you when to start here in a minute. Yes? The middle, so two things all the way across. Yes? The middle two denominators will cancel out with what we multiplied. Yes? No. And when we cross out, because it's been very tempting, we can easily just start crossing things out and going through it. But just be a little mindful when we cross things out, because this one is different in that if we look at the middle term, we do have a single x minus 3 we're multiplying it by, and 1 in the denominator. Did everything cancel out? No, because we have how many x minus 3's there? 2, which means I need a second x minus 3. Because since it showed up twice, we need it twice. Because this is the first time we've had an expression show up twice in a single denominator. So it means x minus 3 has to show up twice in all of them. And it might have been a little weird why I've been saying that, because I've been saying it for the last few weeks. If it shows up twice in one of them, we need it twice. This is why. And if you're not sure you need it twice, list it once. Like we just did. We went through and crossed it out and saw in the middle. It didn't simplify out completely. We needed a second one, so we add it. The first one of the x minus 3's will cancel out. One of the x plus 3's will cancel out. We still have one left. And then the last one, our x plus 3 and x plus 3 will cancel. And what that leaves us with is 4x times x minus 3 is equal to x minus 1 times x plus 3 plus 2 times x minus 3 times x minus 3. Questions on this here? So did having that x minus 3 twice make this problem any harder than what we've had? No, it did give us a lot more multiplication, yes? And the reason I point that out is because to make these quote-unquote harder, all we're doing is adding more of those. More factors, more multiplication, more stuff we have to just take apart at the end to try to find the solutions. And really, it's not making it harder, it's just making it a little more tedious than anything else. Now we look at this here, I'm going to show you a little shortcut. We can distribute the 4x. 4x times x is 4x squared. 4x times negative 3 is negative 12x. Well, x plus 1, or not x plus 1, x minus 1 and x plus 3 didn't show up anywhere else. So let's go on and multiply those two. Now we don't need the parentheses around it when we're multiplying it. One, because there's not a number or a sign in front of it. So none of the signs would change. x times x is x squared. X times 3 is plus 3x. Negative 1 times x is negative x, and negative 1 times 3 is negative 3. Plus. The next one, we still need the parentheses because of that 2. If the 2 wasn't there and it was minus that second expression, we would still want the parentheses because we're going to have to distribute that negative through. If you're not sure if you need them or not, there's nothing wrong with putting them, because it just verifies it in the end. Because if we didn't need them, like for this first one, the set I just added, in the end they just go away. We drop them. Second one, x minus 3 and x minus 3, yes? Didn't that show up earlier? Right. We got that from what? X squared minus 6x plus 9. Because if we wanted to at this point, I could write in this here as x squared minus 6x plus 9. If you don't notice that, that's fine, because multiplying those two together would give us x squared minus 3x plus 9. Negative 3x minus 3x would give us negative 6x. We would still get there. So if we notice that these two came from the original problem, from factoring it, we can replace it with x squared minus 6x plus 9. Unfortunately, we couldn't do that with the x minus 1 and x plus 3 because we didn't factor anything to get those two being multiplied together, so we had to do that there. Combine like terms. Because our 3x and negative x would give us 2x. And in the second expression, we're going to distribute this positive 2. 2 times x squared is 2x squared. 2 times negative 6x is negative 12x. And 2 times positive 9 is positive 18. Questions on this here? Combine like terms. 4x squared minus 12x. X squared and 2x squared is 3x squared. Positive 2x. Negative 12x is negative 10x. Negative 3 plus 18 is plus 15. Be good on getting to this point, yes? Now, again, I really like having that exponent variable with the biggest exponent positive, yes? But it's going to take more moves to keep it positive, yes? Because this subtract, yes? Yes. This should have been, wait, here? Mm-hmm. Yeah, no, you're good. Right, because it seems like it should be here, but we had 2 of the x minus 3s. Yes. Yeah, because the question was, not scroll, if this should have been x plus 3 instead of x minus 3. But since we had to multiply it by 2 x minus 3s, it stayed, and the x plus 3 went away. Awesome, thank you. It's better to ask now than stare at it wondering what happened. Any other questions? So, again, here, to keep that x squared positive, we would subtract 3, because 4 minus 3 would give us a positive. But in order to do that, we'd also have to move the 10x and the 15. We'd have to move 3 things over, yes? So, whenever, again, I'm all for doing less steps, I will move it over. I would subtract. $4x squared, especially here, if it had just been 4x squared on the one side, I'll move it over, I'll fix the sign. And I can show you how to do that. We've done it before. Because if we subtract 4x squared from both sides, we get negative 12x is equal to negative x squared minus 10x plus 15. And then we can add 12x. Giving us negative x squared plus 2x plus 15. Number in front of x squared is what? It's negative 1, yes? Well, in the last problem, we said we're going to have to factor because there was a number other than 1 in front of x squared, yes? So the likelihood this is going to give us fractional answers is almost 0. Which means graphing it is not a bad option. And it crosses in two nice places, yes? Let's see what they are. Negative 3 and 5. Negative 3 is a restriction. So out of these two spots, negative 3 is removed, telling us that the only solution is 5. If we were to factor it, what I would have done is, you can do it one of two ways. Multiply by negative 1 or divide by negative 1. Because if we do that, we get 0 is equal to x squared minus 2x minus 15. The graphs are completely flipped, but they still cross the x-axis at negative 3 and 5. It gives us the same thing. Does that make sense? Because sometimes it's easier to just move that bigger term over and fix its sign than it is to try to move everything over just for the one side. Questions on this here? How do we feel about these so far? I mean, for the most part, what we did previously in this has not been a big jump. We just added the restrictions, yes? Questions on any of this here? So before we start this, I think we feel comfortable with these here, yes? I'm going to add one piece to it because I think this is the last one. Mine looks a little bit nicer than yours because I actually had the computer write this up this morning to change it from my handwriting. This is the last one we're going to look at. Okay? Last one of these here. Now, x minus 1. Where are we at? Okay. Now, the only one we need to factor is our x squared minus x minus 2. And I'm going to go on and tell you it's x minus 2 times x plus 1. Yeah. Because if we work through that, 2 sets of parentheses with 3 spaces, opposite signs, since the third term's negative, factors of x squared are x and x. Only factors of 2 are 1 and 2. Middle term's negative, so we're going to want the 2 to be negative. Now that does give us 3 restrictions. With our x minus 1, we would add 1, telling us x cannot be 1. X plus 1, we would minus 1, telling us x can't be negative 1. And lastly, we're going to add 2, telling us x cannot be 2. Positive 1, negative 1, and 2. And one thing that's nice is, if I remember this problem correctly, none of those are going to come up. None of those are going to be the value. Now, what are we going to multiply everything by? X plus 1, x minus 2. If we start crossing things out, our first one, the x minus 1 cancel. Our middle one, x plus 1 cancel. And the last one, x minus 2, x minus 2, x plus 1, x plus 1. So in some of them, it was nice cancellation. The first one, we have 2 times x plus 1 times x minus 2. Plus, well, 1 times x minus 1, x minus 2, we don't have to have the 1 because it's understood, equals 1 times x minus 1 is just x minus 1. It's the nice one out of the 3, yes? Now, as we've done before, we can look back and see, well, this one's nice. X plus 1 times x minus 2. Because we got that from the factors of the original one, yes? And again, if that's not something that's clear, go on and multiply it out. There is nothing wrong with that. Plus, x minus 1 times x minus 2 did not show up in the original. So we'll distribute this out. X times x is x squared. X times negative 2, negative 2x. Negative 1 times x is negative x. And negative 1 times negative 2 is plus 2. Now, I didn't put parentheses around that because, 1, there wasn't a number in front. We didn't have a number or expression in front of the parentheses that we would have to multiply through later. And 2, the sign in front of those parentheses was a plus, not a minus. If it's a minus, we include the parentheses. If it's a plus, well, the plus isn't going to change any of the signs, so we don't need it. Yes. We can distribute the 2 here. 2 times x squared, squared. 2 times negative x is negative 2x. And 2 times negative 2 is 4. Plus, x squared is the only like term here. Negative 2x minus x is negative 3x plus 2. Well, we can combine like terms again. 2x squared and x squared is 3x squared. Negative 2x minus 3x is negative 5x. Negative 4 plus 2 is equal to x minus 1. So, no more like terms, yes? It is a quadratic. We have an x squared, so we have to get this equal to 0. So it doesn't matter what I move first, really, for these here. We can subtract x. Minus 3x squared minus 6x minus 2 is equal to negative 1. Then we would add 1 to both sides. Minus 3x squared minus 6x minus 1 is equal to 0, yes? Unfortunately, the factors of 3 and 1 are not going to get us to 6. But there is a way to solve it. Quadratic formula. Quadratic formula. Now, luckily for us here, because again, this is going back to our ax squared plus bx plus c, where a in our case is 3, b is negative 6, and c is negative 1. So for us here, we have negative 6 plus or minus the square root of negative 6 squared minus 4 times a, which is 3, times c, which is negative 1, all over 2a. Now, out of all of this here, negative 6 is positive 6. 2 times 3 in the denominator is 6. At this point here, I'd plug everything inside the radical into the calculator. So our negative 6 squared minus 4 times 3 times negative 1 is 48. If that number inside the radical comes out as a negative, no solution, we're done, because that's going to be imaginary. Can't have imaginary solutions with rationals. Now we want to try to simplify it. 30xs, I would use it over the graphing calculator because it will reduce radicals. 4 squared of 3. Questions on this here before we do the last step, and it's not so much anything solving, just simplifying. We feel comfortable with this here? Do both numerators have a common factor with our 6? 6 with 6, and 4 and 6 have a common factor of 2. So everything divides by 2, which is going to turn the denominator 6 into 3, the numerator 6 into 3, and our 4 into 2. Is that one of our restrictions? No. So those are the solutions. Because it is possible to have these irrational solutions as part of our answer. But really it didn't add anything. We just had to plug it all into the quadratic formula and simplify. So that's it. And that is the end of chapter 7.